A quadratic function is any function that can be written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0. So first we're going to compare a linear function versus a quadratic function. So a linear function is a line when we graph it, and the highest exponent on a linear is 1, so it's x to the first power. So when we graph this, a line is a straight line like this. Now a quadratic function is a parabola, that's the shape. The highest degree is a 2, so it's an x squared function, and it looks like a u when you graph it. So here we want to graph this function. So it's just the basic quadratic function, f of x equals x squared. So first let's make an xy chart. So I'm going to plug in numbers for x. So I'm going to pick -2, -1, 0, 1, and 2. So if I plug -2 in for x, -2 squared gives me 4, and that's my y. -1 squared gives me 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So if we go to graph this, I have -2, 4. I have -1, 1. 0, 0, 1, 1, and 2, 4. And if we look at this, this is symmetric. So the x values are opposites, like one's a positive and one's a negative, but they have the same y value. So when I have x is -2, I get y is 4. When I have x is positive 2, y is also 4. So it's going to be symmetric about the origin. So if I were to draw a line down the middle and I folded this on top of each other, it would line right up. So here we have two binomials. So we have 2x minus 1 and 3x plus 5, and they're being multiplied together. So we want to show that this represents a quadratic function. So in order to do so, we're going to FOIL, and then we're going to identify a, b, and c based off of the standard form of a quadratic. So first thing I'm going to do is I'm going to do my first term. So 2x times 3x gives me 6x squared. 2x times 5 is going to give me 10x. -1 times 3x is going to give me -3x. And then -1 times 5 is going to give me -5. So my function, f of x, I'm just going to combine like terms. I get 6x squared plus 7x minus 5. So now we've shown that this is a quadratic, and this is in standard form. My a value is 6, my b value is 7, my c value is -5. So we're taking the coefficients from each term. Here are a list of some of the properties of a quadratic function. So we know that the first bullet point, that the graph is a parabola. Now if the a value, which is the leading coefficient, what's in front of our x squared, if it's greater than 0, so if it's a positive number, the parabola opens upward. So what I like to say is if you're positive, you smile. So it's going to open up like a smile. If a is less than 0, so if you have a negative in front, it's going to open down. So if you're a negative person, you're going to frown. So smile is positive, a frown is negative. The axis of symmetry is the line x equals -b over 2a. That's the vertical line that cuts your parabola in half and makes it symmetric. Then you have a vertex. The x-coordinate of the vertex is -b over 2a, which is the same as the line of symmetry. So once you know the x value of your vertex, that is the line of symmetry. The y-coordinate of the vertex you find by plugging in what you got for the x value into the function, and then solving for y. And then the y-intercept is always 0, c. So whatever that constant term is in standard form is your y-intercept. And then here's just two examples. The one on the left is opening up because a is greater than 0. The one on the right is opening down because a is less than 0. And then we have domain and range. So the domain for any quadratic function is all real numbers. So that's true all of the time. That should be the easiest question. If I ask you what's the domain of a quadratic, automatically it's all real numbers. The range is a little bit different. The range is dependent on the vertex point. So if your graph opens up like the one on the left, the vertex is a minimum point. So you would find your vertex, and the range has to do with our y values. So since our graph is going up, our range would be y is greater than or equal to whatever the y value is of our vertex. So here our vertex is 0, 0, so the y value is 0. And if you look at the graph, it makes sense because all of the y values are positive. The graph is going up. There's nothing in quadrants 3 or 4, so there's no negative y values. In the second one, it's opening down, and we know that the a value must be negative. Here there's a maximum at the vertex instead of a minimum. So it looks like the max and the vertex is at 1, 2. Since the graph is opening down, we're going to say that y is less than or equal to the y value of the vertex, which is 2. So everything 2 and below is part of this graph. If you look above 2, there's nothing there. The graph doesn't go there. So how can you tell if a vertex is a min or a max? Okay, and that's like what I just said before. It depends on the a value, whether it opens up or down. So the first example, because the graph opens up, this is a minimum. And if a is positive, then the vertex will be a minimum point. In the next example, we have a frowny face. It's opening down. So that means that that's a maximum point. So if a is negative, then the vertex will be a maximum point. Okay, how can you find the minimum and maximum points on a calculator? You would put the equation into y equals and hit graph. Okay, then we're going to hit second and then trace to get to the calculate menu. And then we're going to use either number 3 or number 4 if we want to find the minimum or the maximum. So you need to know which way your parabola is going to open before you can choose one. Then once you figure out if you're doing minimum or maximum, it's going to ask you for the left bound, and you're going to use the arrow keys to bring it to the left, and then hit enter. Then you're going to move it to the right, hit enter, and then enter again, and that will give you your vertex. And we're going to do an example together. So first let's look at what our examples are. Okay, so find the vertex using your calculator. So let's look at the first one. So what I'm going to do first is I'm going to go to my calculator and I'm going to plug in 5x squared minus 10x plus 3 into the y equals. Okay, so first thing I'm going to do, I go to my y equals, and then I hit 5x squared minus 10x plus 3. And then I'm going to hit graph. So here I have my graph, and now I know that I have a minimum point. So this is my minimum. So in order to find the minimum, what I'm going to do is I'm going to go to second, and I'm going to hit the button that says trace. So what comes up is a calculate menu. And I know I need the minimum, so I'm going to hit number 3. So you can scroll down for 3 and hit enter, or hit number 3. So what happens is it says left bound. So what you'll notice is that you have a blinking thing that kind of looks like a little spider. Mine's freezing a little bit right now. But you want to bring that blinking object to the left side of the vertex. So you don't want to put it on the actual vertex. You want to put it, here it comes, to the left of the vertex. So my vertex is there, and I don't want it to be right there. So oops, it's going by itself. Oh no. Okay, I have to bring it back. Any day. Here it comes. Mine's a little sensitive. Okay, so I'm going to go about here. Okay, I just want to go to the left. So it doesn't matter if you go here or you go here. As long as you're to the left of the vertex, you're good. So these numbers on the bottom, they don't matter right now. So I'm just going to hit enter. And then it says right bound. So what I'm going to do is I'm going to move the blinking object now to the right side of the vertex. So what I'm trying to do is kind of like isolate the vertex. So I'm going to move this to the right a little bit. Okay, and I'm going to hit enter. So what it's doing is it's isolating that vertex point. And again, these numbers don't matter, so I hit enter, and then it'll say guess. Again, these numbers don't matter. So you're just going to hit enter again. The thing that does matter is this. So once you get the actual vertex point, it'll say minimum, and it'll give you the x and the y. So this x we can round to 1, since it's pretty close to 1. And then the y will be -2. So when I go to write my vertex here, that's at 1, -2. So we're going to just jump down to where it says what's the domain and the range. So the domain of the first one is all real numbers because it's a quadratic. The range, since this opened up, I know that y is going to be greater than or equal to the y value of the vertex, which is -2. Okay, so now I'm going to graph the second one. So I'm going to go to my y equals, and I'm going to plug in -4x² plus 6x minus 7. And then I'm going to hit graph again. Okay, so here's my graph. I have a maximum this time, so I'm going to hit second trace. And do second trace, and I'm going to go to maximum this time, so I'm going to go to number 4. I'm going to do the same process. So I'm trying to look for my blinking thing, and again I want to bring it to the left of that vertex point. So I need to move mine. It's taking a little bit longer than I would like. Here we go. So again, just go to the left of the vertex point a little bit. So I'm going to go to like here. I'm going to hit enter. I'm going to go to the right. And I'm going to hit enter. And I'm going to hit enter again. And then it gives me my maximum. So I have 0.75, comma, -4.75. So now I'm going to write that point, 0.75, comma, -4.75. And then the domain of that is going to be all real numbers. The range, since this one opened down, y is going to be less than or equal to the y value of the vertex, which is -4.75.